Hello world, ladies and gentlemen, welcome back to the Lone Programmer. Today I'm going to teach you how to convert a sentence to its corresponding binary format by using Python. So let's get started. Open your favorite IDE. I'm using Visual Studio Code for my Python. Create a new file and let's save it as binary.py. Okay, so we have the file. Now let's start by importing a module. So import RE, that's the module that we are gonna import. I'll explain the use of RE in a moment. Now next we need to take the string from the user. So string equal to input. So let's have some text like enter the text. Enter the text. Then we are going to create now what's going to happen is that the user, whoever is running the program, will enter a text, and that text is going to be stored inside the variable string. Now we are going to create a list of words out of this text, this sentence. So word list, we are giving the name for the list as word list equal to, now here is where we are going to use the RE module. So RE dot sub, and follow the code with me right now. I'll explain everything to you in inverted commas, bracket, backslash w, square brackets ends, comma, a space, again the variable name string, and then dot split. So what this does is that it substitutes, that's what the sub function does, it substitutes all the characters like full stops, exclamations, etc., all those characters with spaces. All those characters inside the string variable will be substituted with spaces, and after that, using the split function, we separate each word from that sentence and make it a list of words. Now let's take the length. Let's count the number of elements inside the new word list. For that, length equal to, we are using the len function, length word list. Now that we have the length, we need a for loop. For I in range length, we are creating a new list called letter list. Letter list is equal to list function. Inside that we are passing word list I. So what this does is that it takes each word in the word list and convert it into a list of letters. That's what this does. Now we are taking the length of the letter list, the number of elements in the letter list, using the len function. Letter list. Now I'm going to create a new list of Unicodes. Unicode List, and give an initial value as 0. This is just for declaring or creating a list of Unicodes. We have not converted any of these letters into Unicodes yet, but we are going to do it. And once we do it, we need a list to store all these Unicode values. That's why we are creating a Unicode list right now. Once you have created that Unicode list, we need another for loop for j in range LE, that is the length of letter list. Now we are separating each letter from that list of letters. Letter is equal to letter list j. Oops, there's an error. Okay, j. Now the corresponding Unicode is equal to convert a letter, or sorry, a character to its corresponding Unicodes. We have an inbuilt Python function called ORD. The ORD function is used to convert any character, in our case the letter, into its corresponding Unicode value. It is an integer value, just like ASCII. So once the Unicode is taken, we need to append, or we need to add this Unicode value to the Unicode list that we have created. For that we are using the append function. Append Unicode. So once this loop is completed, each letter in the letter list will be converted to its corresponding Unicode, and that Unicode value will be appended, will be added to this Unicode list. But initially we have added a 0 into that list, but we don't need that 0 actually, so we need to pop it out. That's why you're using the pop Unicode list dot pop. In that pop we are giving the index number 0. The index number 0 says that this will pop out anything, any value that is at the index number 0. That means our first value is 0. Now that it's done, I'm going to create what we need is a binary list, isn't it? So what I'm going to do is I'm going to create a binary list, just like we did a Unicode list. Binary list equal to 0, and then again a for loop, just like we did in the Unicode. For j in range LE, the length is not changing, so LE is enough. We don't need to take the length of the Unicode list again, because it will be same as that of the letter list. So now we are separating each number in the Unicode list. Number equal to Unicode list j. Now we have to convert each Unicode number into its corresponding binary format. Binary equal to, for that also we have an inbuilt Python function called a bin to convert a number to its corresponding binary. Bin number. But there's a little bit problem. Like when you use the bin function, what the Python does is that it adds a 0b to the beginning of every binary value. So in our program we don't need that 0b at the beginning of every binary value we take. So we have to strip off that 0b from the left side of the binary value. So we are using .lstrip, and inside that we are giving the value that we want to strip off, in our case 0b. While you're writing the code, you can write your code without this lstrip and see what happens, but in our tutorial I am going to write it. So now that we have the binary value, we have to, to append it to our binary list. So binary list dot append the binary value. binary. Just like we did in the Unicode list, we have an unwanted 0 at the 0th index position. We need to pop it out. So binary list dot pop 0th position. So that is done. Now we have in our hand a list of binary values for a single word. Now we want to print it. For that we are using a for loop. For j in binary list, so that it will loop over all the elements in the binary list and print out the values. Print j. Again, a problem rises. That is, by default the print will print out a single value and then will automatically move on to the next line. We don't need a binary value to be printed in a line. In a one after the other downwards. We need it to be side by side. So that we are using nth equal to a space. A space because after each binary value being printed onto the screen, I need a space between each letter. That's why I'm using it. You will see when we run the program. After that, I'm using another print. This is to give spaces between words. I'll tell you after running the program. 4 spaces and then an end. So that's it. I'm going to save it. Fine. Now this is our code. Okay. Now let's try to run this and see if everything is working fine. Okay. Let me go to the folder. This is my way of accessing a Python. Okay. Now binary.py. Enter the text. So I'm going to write a text. This is a text. There you go. The corresponding binary value has been printed successfully. Now you may see that after each binary digit, each binary section, there is a single space and there is a 4 spaces between some digits. So what this is, that you can count these letters. This is a single letter T. T, H, I, S. This, I, S is a T, E, X, T. That's what this is. So this is the space that we provided between each letter. And this is the 4 spaces that we provided between each word. So this is what the output looks like. So let's exit from this command and let's move on to the code, and I'll explain this code once more to you if you don't understand it at the first time. First, we imported the RE module to separate or filter out some characters from the string. And then we asked the user to input a string. And then the word list, we created a list called the word list, and we used the RE module to filter out characters and add spaces. Then we used the split command to create a list of words out of that sentences. And then we took the length of the word list, that means counted the number of elements inside it, and we created a loop with the length of the word list. And inside the loop we took each word, that means we took the first word, that is the first element of the word list is a single word, and using the list function we created a list of letters. Now, not this point, you need to use the split function to create a list of words out of a sentence, and you need the list function to create a list of letters out of words. Now that's clear. We used the LE variable the len function to count the number of elements in the letter list. Then we created a Unicode list and initialized it, created a list and gave it a value 0. And then using another for loop, we took out each letter from the letter list. That's what this thing does. We took out each letter from the letter list and converted it into its corresponding Unicode value using the ORD built-in Python function. So the Unicode value of all the letters, each letters in the letter list is being taken. And once the Unicode value is taken, we use the append to add this corresponding Unicode value to the Unicode list that we have created. Once this loop completes, we'll get the Unicode value of all the letters in that word. And also we have created, once we have created, we added a 0 at the beginning. We need to take out that 0. We are using the pop to take out that 0 at the beginning. But what we need is a binary function, binary value, right? So we are creating another list called binary list. This is the same way we created the Unicode list. And then using another for loop, we are taking out all the each numbers inside that Unicode list. And then by using an inbuilt Python function bin, we are converting the number into its corresponding binary format. But as I told you before, Python adds a 0b at the beginning of all the binary values. We don't need that 0b. So we are using the lstrip to take out the thing that we don't need at the leftmost side of the value. That means lstrip 0b will take out 0b from the left side of that binary value. So once we have that binary, we will append it to the binary list. And just like we did in the Unicode list, we will pop out the value at the 0th index position. In our case, it is 0. And once this section is completed, we will have in our hands a list of binary values corresponding to a single word. We will loop through that binary list and will print all the binary values separated by a single space. So that's what we saw in the output. Each binary value is separated by a space. That indicates letter by letter a single word. And once that is printed, the loop will end and the loop will restart. Before it restarting, we are giving us 4 spaces so that each word will have a 4 space between them. That's what this line is all about. And once the for loop restarts, the process will repeat with the second word, I value 1, 0, 1, 2, 3, 4, and in that sequence the next word will be taken and the process will be repeated and the binary value of the next word will be printed. And in the next loop, the third word will be taken and the process goes on until the binary values of all the words in that text is printed. So this is how this code works. Actually, we are not putting some effort in converting a letter to its Unicode or a number to its binary. We have inbuilt functions, but what this code gives you the ability is that it gives you the power to decompose an entire sentence into its corresponding root letters. You can use this say like spell checks or finding characters or anything you want to. Basically, you get the power to decompose a sentence to its corresponding letters. That's what this program is all about. So now you know how to convert a sentence to its binary format. You can use this for words, you can use this for numbers, you can arrange the commands accordingly. So hope you like the video. See you in the next video. Thank you. If you like the content, please subscribe the channel and press the bell icon for more videos like this.